Welcome to Learn Yourself. Today we are going to solve some of the questions from the main exercise of structure of atom. This chapter is under CBSE Std-9 syllabus. This is the main exercise from the page number 54. So the first question is compare the properties of electron, proton and neutron. So here we have to compare the properties of subatomic particles. And what all are the subatomic particles? Proton, neutron and electron. So we can bifurcate according to their properties like this, that charge of all the three subatomic particles, then protons are positively charged particles, neutrons are chargeless, electron is negatively charged particle. Then mass of proton, it has a mass, neutron has mass and electron is almost having a negligible mass, and it is 1 divided by 2000 times of that of the proton. Now where are they situated? Where are they in the atom? So they are in the nucleus. Neutron also, they are in the nucleus. They are not in the nucleus and they are out of the nucleus and they are rotating around the nucleus. Any of this you can write it here. Then one important point here is proton count and electron counts are always equal, and that is why our atom is neutral in state, because the positive and negative charge particles are equal in magnitude. That's why the atom is neutral. So here and here the same point you can write, that proton count and electron counts are always equal. Generally proton and neutrons are equal, but when they are different, then the same elements will become isotopes. For example, carbon C614 and C612. So these are isotopes. So sometimes proton and neutrons are different, or you can write sometimes in the case of isotope proton count and neutron count will differ. Our next question is, what are the limitations of J. Thompson's model of an atom? Now here let us recall that which kind of model J. Thompson has proposed. So this kind of model he proposed, and he said that atom is electrically neutral. This positive sphere has all the negatively charged particle embedded on it. So he suggested that this is the model of an atom. Now he stated that atom is electrically neutral because he said that the positive particles and negative particles are equal in magnitude, and that's why the atom is neutral. But series of experiments carried out by other scientists could not explain the results of their experiment by Thompson's model. We know that this is not the correct model of an atom. So see, other scientists, those who were in the continuous process of inventing or discovering something about the model of an atom or about the nature of an atom, their experiments result were not matching with Thompson's model of an atom, and they couldn't explain their observation on the basis of this Thompson's model of an atom. So this was the biggest limitation of Thompson's model of an atom, and that's why this model they did not accept, because their observation, their results of experiments were not matching with Thompson's model of an atom, or they were failed to explain their results with the help of Thompson's model of an atom. So this is how we will frame our answer. Our next question is, what are the limitations of Rutherford's model of an atom? So Rutherford suggested that electrons revolve around the nucleus in the circular path. This is what he suggested after his experiment of gold foil. Now from here our real answer is starting, that but he failed to explain the stability of atom. This was the major drawback of Rutherford's model of an atom, that through his model he failed to explain the stability of atom. Now how this has happened? Any particle in circular motion would undergo acceleration. During acceleration, the charged particles will radiate energy and finally they will lose the energy and finally fall into nucleus. During the acceleration, the charged particle will radiate some energy and they will lose the energy. So, and after, once they will completely lose their energy, they will finally fall into the nucleus. And if these things will happen, and in this case the atom is highly unstable. Whatever he has suggested, that electrons are revolving around the nucleus. If that is the case, then atom should be highly unstable, because they are under the circular motion, they will have acceleration. Once they will have acceleration, they will start radiating their energy. After losing all the energy, they will not have any energy left and they will fall into nucleus. So the complete atom will collapse if this thing will happen. So in this case, atom is highly unstable. But in our nature, all the matters, what all matters are existed, they are stable, they are quite stable. So, but all the matter exist in nature are stable. So this contradiction was the major drawback of Rutherford's model of an atom. If this is the case, then matter are not stable. And if matter are not stable, then how even the universe is surviving? So his model was correct, but his model was failed to explain that why the atom is stable. So the main drawback is he failed to explain the stability of atom. And we have to write all the reason that due to the acceleration, it will radiate the energy, it will lose energy, and it will finally fall into nucleus. And in this case, atoms are highly unstable. Our fourth question is, describe Bohr's model of the atom. So we have to draw this Bohr's model of an atom, and where this is nucleus, and after that 4 successive energy levels, and that is orbitals we have to draw, and it is from K, L, M and N, from inward to outward. Bohr's model of an atom consists of energy levels. Energy levels were K, L, M, N successively from nucleus to outermost side. Based on this model, he gave 2 postulates. This is important. We have to remember this 2 postulates. Only one certain special orbit known as discrete orbit of electrons are allowed in an atom. So he came with a concept of discrete orbit, and he said that only discrete orbit will be there inside an atom. While revolving in discrete orbits, the electrons do not radiate energy, and hence he said that atom is stable, because while revolving, electrons do not radiate energy, they will not lose the energy, and they will be stable in atoms. So these 2 are the postulates from Bohr's theory of model of an atom. So in this we have to draw model of an atom, then we have to explain that what all things he said, and then 2 important points as a part of postulates. The fifth question is, compare all the proposed model of an atom given in this chapter. So this question is very important. This is a consolidated table in which I have noted down all the important points, and all the major points I have included in this. So this question is important in terms of revision also. So Thomson, Rutherford and Bohr's model of atom I have compared here. So first, Thomson's model of an atom. He gave this Christmas pudding like structure of an atom, and he said that in positive sphere the electrons are, or negative charged particles are embedded in it like a dry fruits. And he also said that positive charged particle and negatively charged particle are equal in magnitude, and so the atom is electrically neutral. So atom is positive sphere, negative particles are embedded in it, and he also stated that it is electrically neutral. Now, what is the drawback of the Thomson's model of an atom? That scientists were failed to explain their observations via this model. That he said that it is electrically neutral and this is the model of an atom, but their observation and their results were not matching with this model of an atom. So this was the biggest drawback of this model. Now coming to Rutherford's model of an atom, he gave this structure. He said that in the center of the atom, the nucleus is there. He was the first scientist who gave the name nucleus. And in the nucleus, proton and neutron are there and electrons are revolving around the nucleus. Positively charged center is there and he gave the name nucleus. Electrons are revolving around it. Size of nucleus is very small compared to atom. The whole mass of atom is lying at nucleus of atom. But what was the biggest drawback of this model? That he failed to explain the stability of atom, because they were believing that when electrons are revolving around the nucleus, it will be in the acceleration. The objects which are in the acceleration will radiate energy. So after some time, electron will lose all of the energy of that and then they will fall in the nucleus. And in this case, atom is highly unstable, but atoms are stable. So he failed to explain this concept via his model. So this was the biggest drawback of Rutherford's model of an atom. Now about Bohr's model of an atom, he gave the energy levels of orbitals. He said that there are energy levels like K, L, M and N after the nucleus. He was the first scientist who gave the energy levels concept. And he also stated two postulates in which he said that discrete orbitals will be there and electrons which are present in the discrete orbit will not radiate the energy, and hence the atom is stable. He was the first scientist who said that electrons will not radiate energy even after they are revolving around the nucleus, and hence the atom is stable. So this is the complete comparison of three models of an atom which we are studying in our chapter. Sixth question is, summarize the rules for writing of distribution of electrons in various shells of first 18 electrons. Now we know that there are four orbitals K, L, M and N, and we are filling the electrons as per the rule of 2n square. Where n equals to, we are taking 1, 2, 3, 4 and so on. So according to this, when we are writing k equals to 2 into n, we are taking 1. So k is 2. Then similarly L, 2 into 2 square, so it will be 8. Then M, 2, 3 square, it will be 18. And n equals to 2 into 4 raised to square, it will be 32. So these are the capacity of orbitals. Now electrons will be filled in the orbits as per the rule of 2n square, where n we are taking 1, 2 and 3. And the second rule is, in the outermost shell of the electron, whenever we are keeping the electrons as per their atomic number, when we are reaching to outermost shell, and in that orbits we cannot fill more than 8 electrons. So here K, L, M and N, so if this is the last or outermost shell, then we cannot put more than 8 electrons in this. So even though M's capacity is 18, we cannot put more than 8 electrons in this. As per 2n square, k equals to 2, L equals to 8, M equals to 18 and N equals to 32 are the capacity of this orbitals. So these two are important rules to distribute the electrons. The seventh question is, define the valency by taking example of silicon and oxygen. So first we will see that what is the valency or what is the combining capacity of silicon. To do so, first we need to remember the atomic number of all the elements till 20. So silicon's atomic number is 14. So now let us distribute this electrons in our orbitals. So K shell has 2 capacity, L has 8, M has 18 and N has 32. So now let us put here 2. So now left electrons are 12. So here we can put from 12 we can put 8. Now 10 we have already completed. We have now 4 electrons. And in outermost shell we cannot put more than 8 electrons. So we can put here 4. So this is how we are writing this. Now 2, 8 and 4 are there. So this is the electronic configuration of silicon. So silicon is lacking by 4 electrons in its outermost shell. Which is the outermost shell for electron? M shell is the outermost shell for electron. And outermost shell should have 8 electrons in total. If we want to fill completely the outermost shell, then it should have 8 electrons. Now, according to silicon's electrons, 4 electrons are there in outermost shell. If silicon wants to be completely stable, silicon wants a completely filled outermost shell, then it requires 4 electrons in its outermost shell. So, its combining capacity or its valency is 4. Why? Because it requires 4 electrons in its outermost shell. The electrons which are extra in outermost shell or the electrons they required in outermost shell to be completely filled is known as their valency. It is depending upon the nature of the element. If they are non-metals, then they will gain the electrons. If they are metals, then they will lose the electron. They will lose the electron, and by losing electron, that will define their combining capacity. Here there are 4 electrons. So it is lacking by 4 electrons, and hence the valency of silicon will be 4. Now moving towards oxygen. Oxygen's electronic number or atomic number is 8. So K, L, M and N. Here we are keeping 2 electrons. Now 8 minus 2. So now we have 6 electrons. And the capacity of L shell is 8. So we can put 6 electron in L shell. If you have any doubt that how to write electronic configuration, then I have given the link in the description of the video that how to write electronic configuration. Please go through that video and clear your doubts and then come back to this video. Now here oxygen required 2 electrons to complete its outermost shell. Because once we are adding here 2 electrons in L shell will be completely filled and it will be with 8 electrons. So the valency of oxygen is 2. Why? Because it is lacking with 2 electrons. So that's why the valency of oxygen or the combining of capacity of oxygen is 2 here. The next question is average atomic mass of sample of an element X is 16.2 U or unit. What are the percentage of isotopes 16X and 18X in the sample? So these are 2 isotopes and its average atomic mass is 16.2. Now we have to find out that in what percentage they are present in average mass of unit. So how we will calculate that? So first we are writing here this. So 16 we are taking. So first isotope we are taking and into multiply with A divided by 100, because we do not know that which percentage this 16 is present in average mass. So we are taking here A divided by 100, then plus 80. because we are taking average atomic mass, and these two are the summation of two isotopes atomic number. Now here we are writing 100 minus A, because this two term will be equal to 100, because we are taking percentage always with 100. Total percentage will be 100. So from 100, some of the percentage will be this and some of the percentage will be this. If we are guessing that this is A, then this will be 100 minus A and divided by 100. Now this plus this equals to how much is our average atomic mass. So 16.2. When we are adding this two, we should get 16.2. Why? Because that is our average atomic mass unit for this element X. Now we need to solve this as per our mathematics rule. So here first we are writing 16A divided by 100. Here according to BODMAS, first we will write 1800 divided by 100 plus, first we will multiply with this and then we will multiply with this. So we will get here 18 and this will be minus, because here minus is there. So 18A divided by 100 and we will get here 16.2. Now let us solve this. So this term and this term is equal AA, so we can solve this. So here we will get 16 minus 18. So we will get here minus 2A divided by 100 plus 1800 divided by 100. 1800 divided by 100, and here we will get 16.2. So here we can simplify this like 1800 minus 2A divided by 100. Why? Because in both denominator 100 is there, and equals to 16.2. Now we can take this 100 towards this side. This is in the denominator, so it will go in numerator. So it is 1800 minus 2A equals to, when 16.2 will multiply with 100, then it will become 1620. Why? Because it is 162 divided by 10 into 100. So 1010 will get cut and we will get here 1620. So 1620 we will get here. Now minus 2A equals to 1620 minus this 1800 we are taking towards this side. So this will become negative. So it will become 1800 and that will be negative. Here we will get 80 out of this subtraction. So minus 180, and here it is minus 2A. So from both the side minus minus we can eliminate, and we will get here 2A equals to 180. Now this 2 we can take towards this side and it is in the multiplication. So when we are changing the side, it will go in denominator. So A equals to 180 divided by 2 equals to 90. So A is 90. So here our A is 90. So 100 minus 90 we will get here 10. So for this sample whose mass is 60, the percentage of this is 90%. And here whose mass is 18, its percentage is 10%. How we got this? Because A is 90. Here 18, 1 we have counted as 100 minus A. So 100 minus 90, so this is 10. So the mass number 18 has 10% share and mass number 16 has 90% share in this 16.2 unit average mass unit. So whenever you are getting this kind of sum, first you write both atomic mass, then you guess first atomic mass percentage as A, and then the latter one will be 100 minus A, and then you solve according to our mathematical rule, and the thing which we will get at the last will be our A, that is percentage of first isotope. After you will deduct this number from 100, you will get percentage of second isotope. So this is very easy. Only you need to remember is how to arrange these numbers. 12th question is, if Z equals to 3, what will be the valency of the element? Also name the element. Now this can be asked for any of the element till atomic number 20. So here Z equals to 3 means atomic number is 3 for this element. Now valency, when we are checking, first we have to write that electronic configuration. From that only we will identify what will be the valency of this element. So for that K, L, M and N, we have how many electrons here? 3. So we will distribute 2 electrons according to the maximum capacity of K shell. Whatever left is 1. Now we want outer shell to be filled. So here L has only 1 electron. Either we need to give 7 electron or it should lose 1 electron. Which one will be the easy for this? This is easy and this is not. To gain 7 electrons will be very difficult compared to lose 1 electron. So what it will do? It will lose this 1 electron. When it will lose this 1 electron, it will gain 1 positive charge. And this 1 electron is excess, so the valency of this element is 1, because this 1 electron it will lose and it will have K shell completely filled. So its valency is 1, and this element is lithium. From atomic number itself we will get to know that this is lithium and its valency is 1. Once it will lose this 1 electron, it will become lithium plus, lithium ion, and this is metal, so it will be positive ion, and it will lose 1 electron and it will have K shell completely filled like helium, the noble gas. So that's why its valency is 1. Similarly, can be also asked for Z equals to 9. So Z equals to 9 is which element? It is fluorine. Now what will be the electronic configuration of fluorine? It is 2. Whatever left is 7. So here we are keeping 7. Now to complete the outermost shell, either this fluorine has to lose 7 electrons or to gain 1 electron. Then only its outermost shell will be completely filled. If we are losing this 7 electron, then its K shell is completely filled. If we are gaining 1 electron, then it will be having 2 orbitals, 2 and 8, and both will be completely filled. Now which one is easy? This is easy. To gain 1 electron is easy rather than to lose 7 electrons. So it will gain 1 electron and it will become 2, 8, and it will become fluorine minus. It is gaining 1 electron, so it will make fluoride ion, 1 negative ion with 1 negative charge, and fluoride ion. And here the valency of fluorine is 1. Why? Because it is gaining the stable state after gaining 1 electron. In both the case, the valency of element is 1, 1. But here it is achieving by losing 1 electron, and here it is gaining by, achieving by gaining 1 electron. This is how we will frame our answer, that Z equals to 3 has electronic configuration 2, 1, K equals to 2 and L equals to 1. To make outermost shell completely filled, it will lose 1 electron and achieve electronic configuration like K equals to 2. Here we can also write like helium. We can also write like this, that helium is a noble gas and it will become stable like helium. Since it is losing 1 electron, its valency is 1. Its combining capacity is 1. That means it is able to donate 1 electron. That's why its combining capacity is 1. And here the element name is lithium. 13th question is composition of nuclei of two atomic species X and Y are given as under. So X and Y are two elements. Here X and Y are two atomic species, and in X proton count is 6. Y the proton count is 6. So that means both has atomic number 6. So they are probably the same element. Now neutron count is different in both of them. Here it is 6, here it is 8. Give the mass number of X and Y. What is the relation between X and Y? So first let us write the mass of X. What will be the mass of X? This is proton count and neutron count of X. So 6 plus 6. So number of proton plus neutron. So here 6 plus 6, it will be 12. So mass of X is 12. Now here mass of Y is number of proton plus neutron. It will be 6 plus 8. This is Y, and the proton of Y is 6. Neutron of Y is 8. So 6 plus 8, it will be 14. So here the mass of Y is 14. Here they have same proton number. So they have same atomic number, but they have different mass number. So they are isotopes of each other. They are isotopes because they have same atomic number. So they are one element. These two elements are same, but their mass number is different. So that's why they are isotopes of each other. Question 14 is, in this we have to write true or false. So first statement is J.J. Thompson proposed that the nucleus of an atom contains only nucleons. No, this is false. He gave a structure like Christmas pudding and he said that atom is neutral. This was not said by J.J. Thompson. Second is a neutron is formed by an electron and a proton combining together. Therefore, it is neutral. Now, neutron is not formed via electron and proton count. So, this is also false. Third, the mass of electron is about 1 divided by 2000 times that of the proton. So this statement is true. Mass of electron is about 1 divided by 2000. So 2000 times that of the proton. Then fourth statement is an isotope of iodine is used for making tincture iodine, which is used as medicine. So this is true statement. Question 15, 16 are multiple choice question. So the question is Rutherfords alpha particle scattering experiment was responsible for the discovery of atomic nucleus, electron, proton and neutron. So it was responsible for discovery of atomic nucleus. Rutherford was the first person who said that the mass of atom is concentrated in the center of the atom, and he has given the name to the center of the atom, and that is nucleus. 60. Isotopes of an element have same physical properties, different chemical properties, different number of neutron, different atomic number. So when an element has isotope, it has same atomic number, different mass number, same chemical property and different physical property. So these are the characteristic properties of isotopes, that it has same atomic number, different mass number and different neutron count. Then same chemical property and different physical property. So here Same physical property? No. Different chemical property? No. Different number of neutrons? Yes. Different atomic number? No, because it is the same element. So they are sharing same atomic number. So this one is the correct out of this 4. And these are the characteristic properties of isotopes. 17th question is number of valence electrons in chloride ion. We know the electronic configuration of chlorine, that is 2, 8 and 7. Why? Because its electronic number or atomic number is 17. So chlorine's electronic configuration is 287. When it is Cl minus, when it is chloride ion, it is accepting 1 electron in outermost shell and it will become 288. Now this will be the electronic configuration of chloride minus ion. Now what they have asked, that number of valence electrons. What are the valence electrons? Electrons which are present in outermost shell will be the valence electron. So it is 8. So the correct answer is 8. Now next is correct electronic configuration of sodium. So sodium is 11. Its electronic number is, or atomic number is 11. So its electronic configuration is 281. In K shell it is 2. Then 8 and last outermost shell has 1 electron. So this is the correct electronic configuration. 19th question is complete the following table. In this they have given atomic number, mass number, neutron count, proton count, electron count, and we have to write the name of the element. So some of the details are missing and those details we have to fill in. So first we were taking atomic number 9. Now as you have remembered all the atomic numbers and elements till 20, from the atomic number we can guess that which is this element. So atomic number 9 is for fluorine. So this element is fluorine. Now mass, we have atomic number. So this is number of proton. Atomic number is equal to number of proton and is equal to number of electrons. So this 9 we can copy here. Now mass, number of proton plus number of neutron. When this 2 will be, the sum of this 2 will give us number of mass. So 10 plus 9 will give us 19. So mass of fluorine is 19. Now next, atomic number is 16. So atomic number equals to number of proton, number of electron. So here this 16 we can copy here, 16, 16. The element name they have already given. Now mass is 32. So 32 divided by 2 also we can do, or 32 minus 16. After that we will get number of neutron. Why is it so? Because number of neutron, number of proton will give us atomic mass. Now when we are finding this, so we are writing N equals to A minus P. P will change its side and it will become negative. So when we are subtracting number of proton from mass number, we will get neutron count. So either way we will get 16. But it is better to subtracting from atomic mass. If sometimes it is isotope, then it will be easy for us to find out. Now atomic number we have to find out. We have number of proton. So number of proton is equal to atomic number. So here we can write 12. Now atomic number is equal to number of proton is equal to number of electron. So 12. All these three will be always equal. Atomic number, number of proton and number of electron. Now we have mass 24. So number of proton we will subtract from mass. So we will get here 12. 24 minus 12 we will get here 12. Now here mass is 2, proton is 1. Now when proton is 1 we can write here 1. Atomic number is 1 and here electron number is 1. When number of proton is 1 and mass is 2. So 2 minus 1. So we will get here neutron 1. So this element is hydrogen. Here atomic number is 12. So this element is magnesium. Now here, for this atomic number 1, the mass is 1. If we will write here hydrogen, then hydrogen's atomic number is 1 and its mass is also 1, because in hydrogen the neutron count is 0. So here this is the isotope of hydrogen and it is deuterium. Now here this proton is 1, so atomic number is 1. Now here neutron is 0, so mass will be 1. Neutron is 0, proton is 1, electron is also 0. So this is H plus ion. Why? Because in hydrogen 1 electron should be there. When there is no electron, it will become H plus. So this is hydrogen ion. You can write here H plus or you can write here hydrogen ion. So accordingly you have to choose. If there is change in electron, then they might be ion of that particular element. So if they have given different electron number compared to proton count, then it must be ion of that particular element.